back. In the last class, we have discussed about magnetic field. Students, did you understand that? It's a very important topic, so study well. Today we are going to discuss another important topic in this chapter. Shall we start? Okay. Are magnetic lines of force present in all dimensions around a magnet? Yes, magnetic lines of force are experienced in all dimensions. The number of magnetic lines of force passing normal to unit area is the magnetic flux density of that region. And remember one thing, magnetic flux density is greater at the poles of a magnet. Carefully observe the magnetic lines of force when two like poles are brought near. Magnetic lines of force bend sideways when like poles of magnet come near each other. Isn't it? Next, we are going to see the magnetic lines of force when two unlike poles are brought near. What do you see? Yes, when unlike poles of magnet come close to each other, the path of the magnetic lines of force is from the north pole of one magnet to the south pole of the other magnet. Isn't it? From these two figures, can you find out the peculiarities of magnetic lines of force? Yes, the magnetic lines of force do not intersect one another. The magnetic lines of force bend sideways when like poles of magnet come near each other. And when unlike poles of magnet come close to each other, the path of the magnetic lines of force is from the north pole of one magnet to the south pole of other magnet. Now, you have understood that a magnet attracts magnetic substances. What are the substances attracted by a magnet? Yes, iron, cobalt, nickel and alnico are some of the substances which are attracted by magnet. Does a magnetic substances attracted by a magnet get a magnetic force? Let's see. Bring a pin in contact with the pole of a bar magnet as shown here. Is it attracted? Yes. What happens when you bring another pin to the free end of the pin? See what happens here? Here, the pin acquires magnetism by the presence of a magnet. Once again, a magnetic substance acquires magnetic power in presence of another magnet. This is magnetic induction. Then, what about its polarity? Whether under contact or non-contact, the polarity of the magnet produced by induction will be like polarity at the farther end and unlike polarity at the nearer end. Next, we are going to see magnetic induction in soft iron and steel. Place a soft iron on any pole of a bar magnet as shown here. Truss the free end of the iron piece in a heap of pins and take it out. Holding the soft iron piece, removing the bar magnet. What do you observe? Yes, all the pins fall down. Repeat the experiment using steel bar and observe what happens when the steel bar is removed from the magnet. Yes, the pin do not fall down from the steel bar. I will explain. Both the rods acquire magnetism in presence of a magnet. But soft iron piece is not able to retain the magnetic property when the magnet is removed from it. But steel bar is capable to retain the magnetic property once it has gained through induction. So, The ability of a magnetic substance to get magnetized under the influence of a magnetic field is susceptibility. Retentivity is the ability to retain the magnetism thus acquired. Soft iron has low ability to retain the magnetic power which it has acquired. That is, retentivity is low, but it is easily magnetized. That means it has greater susceptibility. In the case of steel, it has the ability to retain the magnetic power once it has acquired. So, retentivity is greater and is not easily subjected to magnetic induction. So, susceptibility is very low. On the basis of this, which one is suitable for temporary magnet and which one is suitable for permanent magnet? Soft iron get magnetized easily, so it is suitable for making temporary magnet. And steel retain the magnetic power once it has gained. That is, it has greater retentivity, so it is suitable for permanent magnet. Students, let's conclude today's session. Today we have discussed some important aspects about magnets. Study well and see you in the next class. Thank you.